Hello everyone and welcome again. In this video we'll have a look at GP2 pin of the PIC10F200 microcontroller. We're gonna set this pin to the usable digital state. So let's create a new file, a new project, standalone project. So we're gonna use the baseline, okay, 10F200, and oops, I'm using my PIC10F200. Okay, click next. I've got my XC8 compiler. I'm gonna call this file GP2 underscore 10F200. Okay, I'm happy with the location and everything else, so I click finish. Now on this project, let's create a new source file. New main C. Okay, now this file I'm gonna call GP2 underscore 10F200. Okay, happy with that. Click finish. So in our main file, I'm gonna delete the return. So let's set what we want to do is we want to set the state of all the usable pins to the high state, and we're gonna probe their state to see if they are high or low. So first thing we have to do is set the direction of the port. So I'm gonna say trace, let's move this away, GPIO is equal to, now let's use the binary. Now we know that this port has got only 4 bits, 4 lower bits, so all the upper ones I can call them 0. Now GP3 can be input only, I leave it as input only, and 3 other ones usable I'm gonna leave as an output. Now let's go and program our 3 bits that we can use as an output. So in here we're gonna say again in binary the 4 of them 0, the 4 of the top ones they're not there basically. Okay, and the 4 lower ones, we know that the GP3, which is the 4th bit, can be only input, so I'm gonna leave it as 0. All the other 3 ones I'm gonna set to the high state, so I'm expecting be around 5 volts there. Okay, let's build the project, see if we got any mistakes there. No, nothing. Okay, so let's build and program it straight to our PIC microcontroller, connecting to the programmer. Okay, now I see this error because I don't have any separate power supply to the board for this project. So I'm gonna quickly double click there, and to the settings I'm gonna go to PIC10F200 settings, to the power options, and I'm gonna power it up from the PIC microcontroller 5 volts. I'm not drawing any massive currents or anything else, so I'm happy to power it up from the computer, from the PIC10F200. Right, let's try to build and program it again straight away. And we've got program verify complete. Great, let me just bring this a little bit smaller. So this is our data sheet for this PIC10F200. Obviously it has got the data for other devices as well. Let's go down to the pin diagram, and this is our PIC10F200. So we've got GP0, GP1 and GP2, where we be expecting the high states according to our program. GP3 can be input only, so we're leaving this one off for the purpose of this project. Great, so let's move this down. Now on our board, what we have here is we've got our PIC10F200 connected through the jump wires to our PIC10F200. In here we've got the LED, red LED, and the current limiting resistor. By using the orange jump wire, we'll be probing the state of the 3 pins that we have here. Okay, so let me just zoom in a little bit more on the critical parts. Great, I think that will do. So now according to our program, we've got GP0, 1 and 2 high states. So let's use our jumper wire. Now GP0 is here and it is high. GP1 is here and it is high. GP2 is here, and we see nothing. Why is that? That GP2 is not reacting to our program. So let's go back to the datasheet and learn a little bit more on our GP2. As we can see in here, GP2 is used as a general purpose input-output pin. T0 CKI, what is that? We don't know. And FOC, what is that? Okay, let's have a look. Let's have a look a little bit lower. Actually, let's do this. Okay. Let's go to the special function registers here, or actually pinout description. Stop here. Okay, GP2. What we have is GP2 as can be used as a general purpose bidirectional pin. T0 CKI. So that's a timer 0 clock input, comparator and oscillator input. So what we're interested in is this option, the 0 CKI. We know this is timer 0 clock input, so let's learn a little bit more about this by using the special functions register table. There we go. Okay, special functions registers. So in here, that option is here under the option register. Bit number 5 is D0CS, what we'll be looking for. Now let's notice that this option register is all high on the power up, on the power on, power on reset. So let's go down for a moment. That's the status register. Nope. Okay, go down. Yep, we got option register here. So in this option register, what we have to notice is this pin, this bit 5. What it says here is if the T0 CS, which is that timer 0 bit, is set to 1, it will override the tri-state function of the T0 CKI pin. So what does that mean? That at the moment, if we have to write instruction to the option register, otherwise that pin GP2 will always be used as a timer 0 clock input. So what we have to do is on the time option register, we have to set the bit 5, which is T0CS, to 0. And that will allow us to use this pin GP2 as a general input output pin. Okay, so let's go to our program. Now above all that, we're gonna say option is equal to. Now in binary, so we can easier see that, I'm gonna be going from the top to the from the highest highest bit to the lower one, to the lowest one, and we're gonna see what I'm doing in here. So I'm not gonna be affecting anything else apart from the bit 5. So bit 7 I'm leaving it as a high, as a 1, sorry, bit 6 as a 1, bit 5 I want 0, and the rest of them I'm just gonna leave them as 1s, because that's their initial status on the power on or reset. So we've got 2 4 and 2 4. Okay, that's all changed. So let's build and program now and have a look what is happening now with our PIC microcontroller bits. Okay, 0 is high, 1 is high, 2, there we go, is high. Now we've got access to this bit because the option register switched off the timer function. The bit GP3, we know we can't use it because it's input only. So guys, this is what you need to do to allow your pin to be used. Some other PICs might have it as well. Then what you have to do is just go to option register, check on your datasheet which bit is responsible for the timer 0, and just basically switch it off. Okay, thank you very much. I hope that was useful, and I see you next time. Bye.